once again, let's put all these receptors in the line, and let's put here M1, M3, M5, and alpha-1 adrenergic receptors. All these receptors are coupled with GQ protein, right? But we should remember that acetylcholine is a ligand for M1, M3, M5, and epinephrine and norepinephrine are ligands for alpha-1 adrenergic receptors. M2, M4, and alpha-2 receptors coupled with GI or G inhibitory protein. Yeah, and again, acetylcholine is a ligand for M2 and M4, and epinephrine and norepinephrine is a ligand for alpha-2 adrenergic receptors. And beta-1, beta-2, and beta-3 receptors have common ligand epinephrine, norepinephrine. But they coupled with GS, with G stimulatory protein. And both these proteins, they regulate activity of adenylate cyclase. The only difference is excitation of M2, M4, and alpha-2 receptors causes inhibition of adenylate cyclase, and excitation of beta-1, beta-2, and beta-3 receptors causes stimulation of adenylate cyclase. Yeah, so we can put minus here. It means inhibition, and plus here is a stimulation. And adenylate cyclase responsible for conversion of ATP to cyclic adenosine monophosphate, and as a result we have different cellular effects. Yeah, different effects. What is interesting? Stimulation of M2, M4, and alpha-2 receptors inhibits activity of adenylate cyclase, but blockade of these receptors will have opposite effect, will stimulate activity of adenylate cyclase or enhance activity, yeah, or decreases inhibition, and vice versa. Excitation of beta-1, beta-2, beta-3 receptors stimulates adenylate cyclase activity, and blockade of these receptors will inhibit adenylate cyclase activity. Yeah, adenylate cyclase activity.